no calculator. This FRQ is going to look just like this, okay? It's going to have the same exact questions. A, B, C, and D will be the same exact questions. The only thing that will change is the table of values, okay? So very, very similar. And it tells you that this table of values represents an exponential function. Shocker. That's what we've been doing a lot of, right? So it says to use limit notation to state the end behavior. So I'll make this like worth 2 points. 1 point if you get the limit notation correct, and the other point if you have the right end behavior. So let's practice our limit notation. Always start with LIM of whatever the name of the function is. So it should be somewhere up there what the name of it is. This one is called h of x. And then we say as x approaches something, we'll fill that in a minute, equals something. So having that for the left and the right hand side, just being able to set it up correctly, I'll give you a point for. Then, of course, we want to say for the end behavior, that's as x goes to the left and as x goes to the right. And it doesn't matter what order you put those in, okay? So then you look at your table of values, okay? So as x gets smaller and smaller, going to the left, what are the y values doing? They're actually getting smaller and smaller as well, forever towards negative infinity, okay? Now, going to the right, our y values are not going towards positive infinity. Look, these numbers are not getting huge really fast, like they were getting small really fast over here. They're getting really, really close to a very specific number. What number is that? 4. That's it. Okay? Determine the domain and range. A lot of times this is easier when you have the graph done. Domain, though, is easy on this one because the domain of all of these, no matter what the numbers are, is going to be negative infinity to infinity. So remember, use your interval notation on a test, okay? In the homework, sometimes we make some shortcuts and stuff, and that's fine, but for the AP exam, they want interval notation, so that's why on my tests, I want to make sure you guys use interval notation. All right, and so the range, I'm going to save till the end, just because I know in step D I have to sketch the graph, and I'll just show you it's a lot easier looking at the graph. I mean, it's fine if you can do it without the graph, that's great, you know, of course, but we can save that. All right, so let's go to the next part. What is the HA? Don't worry about explaining, okay? Just name what our HA. The HA is going to be y equals something. What is that something? Nope, that's my y-intercept, okay? That's going to be my y-intercept. Nope, it's asking for the horizontal asymptote, okay? Yeah, remember what a horizontal asymptote does. It stops you from going further up or further down. So it's stopping us. That 4, we're approaching it. That's what we are. Remember end behavior? Let me stop and start over. Horizontal asymptotes are sometimes called end behavior asymptotes because it affects the end behavior. So those are going to be the same number. Just like this one. Okay. Can I just write 4? No, it's a line. You have to write y equals 4. Okay. And then to sketch a graph, okay, we just said that there's going to be a horizontal asymptote at y equals 4. It said to label the y-intercept and the horizontal asymptote. There's the horizontal asymptote. The y-intercept is whatever y is when x is 0. So that's right there in the table for you. Let's call that the y-intercept. And then just make a graph that goes through that point. So remember, going towards negative infinity is going down. But as it gets closer and closer to 4, it makes it turn, right? It stops it from going up forever. So now it's easy to go back and see the range. Remember, the range is from smallest to least. We start down, so that would be negative infinity up until what? 4, parentheses or bracket. Parentheses. Remember, that means we're not including the 4. By definition, we can't touch the 4. 4 is not one of the points on our graph, okay? So we're saying everything up until you get to 4, but not including 4. So parentheses are required here, okay? Good on that one. That one's the one you're doing tomorrow. Same exact questions, just different table values. Wednesday, we'll do the graphing calculator version. Guys, this is where we get to practice doing intersection 3 times, okay? So remember, when you take the test, you have to know how to do the calculator parts. I'm not helping with calculator stuff. Okay, so basically we have 2 exponential functions representing, one is for the population of ladybugs over time in years, and a population of some nasty beetle time in years. Okay, so it represents the population, and it asks for the initial population of each. Remember, initial, this is your A sub 0, your y-intercept, your initial amount. It's right there. There's no calculator work to do. It's just knowing that. So there are 2,000 ladybugs when they start this whatever, and there are 3,600 beetles. That's it. That's all I have to write. Okay. Part B, how many days, that's the question, will it take for the population to reach 5,000 ladybugs? So time is what we don't know. It says it right there, how many days. So that's T. What we do have, though, is the population of ladybugs. So that would be L of T. This is intersection. So clear your RAM. Go up to y equals and type in the ladybug equation. Don't forget where the E is. E is above natural log, ln. So you have to hit second ln, and it puts the E on your screen with the power there, 0.025x. And then my second equation is y equals 5,000. Horizontal line at 5,000. Now listen, I can hit graph right now and I'm not going to see anything because we're telling the graph, our graphing calculator, to go up to 5,000. That's a horizontal line way up at 5,000. Right now my graph is defaulted to 10. So before I even bother graphing it, I'm going to go right to my window and change my y max from 10 to, I don't know, maybe 6,000. And let's see if we can see the intersection. Normally, you have to move your x over to the right more, which we're going to have to. So there's my exponential function. There's the horizontal line. I need to go further to the right. So what do I put there? I don't know. Let's try 50. Try 100. Try something. And so there's my exponential function, and there's my intersection. So now I'm going to go to second calc. Now look what happens when I hit 5. Oh, this one's not too bad. Sometimes my writing is like right over. When I did this earlier today, I must have picked a different number. I didn't go high enough. So even though I could see the intersection, this writing was like over it. So I did go back and change my window to a little bit higher to get out of the writing. But I can see everything pretty clearly here. Guys, intersection is the easiest one. You really don't have to do anything except hit enter a bunch of times. Okay, so it's enter, it stamps it there, it moves it to the horizontal line, enter, guess, yes, and then you can see 36 and a little bit more is the number of, is it years or is it T is days? Thank you. So this would be, what would we put as our answer? Because it does matter how I write this. It would be 37, good, because it's 36 and some more. So it's in the 37th day. Sometime on this 37th day, we will be, you wouldn't want to, right, so you'd say 37, right? Okay. All right, let's do, it's the same question. How long will it take for the beetle population to be cut in half? So right now it's 3,600. Half of that would be 1,800. You could do that on your calculator if you can do it in your head. This is calculator active. Clearing my RAM and doing the same exact thing I just did, except with 2 new equations. So 3,600 parentheses 2/3 to the power of 0.075x. My horizontal line is 1,800. I already know I'm going to have to move my y max up from 10. So like, I don't know, let's put in 2,500. I don't know, pick something and see what we get. All right, I'm not seeing it, so I can see my horizontal line. Let's move to the right and see if maybe we see it over there. So I'm at 10, maybe put in 50, put in 100. There's my exponential function. We weren't over to the right enough to see it, and there's my intersection. So second calc, number 5, enter, enter, enter. Negative 10 and 50. I didn't touch them. So I did 50 and 2,500 on my maxes. All right, so second calc, intersect, enter, 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 and you should get in the 23rd day, right? 22 and a little bit more. It'll take 23 days for our beetle population to be cut in half, is what it's saying. And the last one is, will the two species ever have the same number of insects? If so, when will this happen? How many insects at that time? How do we get to our answer? Guys, this is intersection again, but it's intersection of these two. So instead of clearing your RAM, it's okay if you already did, but I already have the second one typed in there. I don't need to retype it. All I'm going to do is go to my Y2, clear out the 1800, so hit clear on the 1800, and type this one in. Doesn't matter which one's first, which one's second, right? So I don't have to type it twice. Save me some time. Whoops, 1 second. E to the power of. So wherever the two functions intersect, that will give us the days, how many days it took. That would be the x value. The number of insects at that point would be our y value. All right, so you can see there's my two, but I need to go up higher. I can see they cross up higher. So window, I don't know. My y max is already at 2,500. I don't know. Let's put in 4,000. Making that up every time I do something different because there's no wrong answer. Lots of right answers, I should say. All right, so there we can see the intersection, same exact thing we've done a bunch of times. Second, calc, 5, enter, 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 and I get 10.6 something. That's 11 days. So will they ever have the same number? Yes. Because there's an intersection, yes, they will. When does that happen? 11th day. How many will they have on the 11th day? And we would round that with normal rounding. 2,607. Yep. 2,607 insects. And how did we know that? Intersection. On our calculator. That would be good. Okay? So I did make this video. So if you want to watch me do this one again, maybe tomorrow night when you're getting ready for the calculator portion, you can always go onto Canvas.